Hi, my name is Tiffany Rhea. I'm a software engineer and test with group pipeline authoring here at Gitlab. It's an honor to be here today and discuss with you about quality at Gitlab. Let's begin. So today we will cover some topics about what quality assurance is, why is it important, especially in software development, what are the different types of testing, and what are the test approaches and methodologies that are being used today in software testing. And also I'd like to mention the difference between quality engineer and the software engineering test as well, and very quickly show you how we test things here at GitLab. And also like to share with you some essential skills that you might need if you ever consider to be a software engineering test. Okay, so what is quality assurance, or also known as QA? So it is a very important phase in any product development process, really, and not just software, any type of product nowadays, food, car, so on and so forth. But for the class, let's just assume the product we're talking about is software. And so quality assurance will make sure that when we implement a new feature, that feature satisfies the product design requirement exactly. And when do we start testing? Well, I think we should start testing as soon as the design phase has begun. And also keep testing throughout the entire development life cycle. We will start testing when we have the very first unit of code implemented. And then after we have create all the unit of codes needed for a fully functional feature, and we combine them, we will then introduce a test for that feature itself. And then we will adhere that feature into the main product. And then we will need tests to make sure that the introduction did not break the product. The product works as it was before and with the new implemented feature. And then after the test is passed, we can now introduce this feature to our user, normally known as the deploy process, deploy to production. But the testing doesn't end here. We will keep testing, we will keep monitoring the behavior of the product now that it's in the real life environment, how it performed. And if there is any escape bug that we haven't accounted for, and when the development cycle repeats, testing repeats. And why is testing important? Well, it is very important to make sure that the product meets stakeholder demands and expectation. And what I mean here is that, for example, in your team, a product manager will come up with a request for a new feature, and he or she will list out all the requirements that this feature should work and all the details. And in our test, we have to make sure that the implementation meets every single requirement. And also hopefully capture any defects and any exception that hasn't been handled as soon as is implemented before it gets to production, of course. And also with thoroughly testing, we can prevent a lot of major product outages or customer facing issue that can cause a very bad impact on the business in general. And with the good, strong product, we can be confident that our product is competitive to all of its rivals in the market, which makes drives the business and customer confidence. We can build customer trust over time, reduce churn rates, boost sales and revenues. Very, very important. What are the different types of testing? So as you can see here, some types of common types of testing. First, we have user experience, also known as UI testing. We will make sure that all the UI components are rendered when we open up a web page, for example. All the buttons appears aligned, the colors right, the locations of the components are as expected. Nothing's out of place, nothing placed like into each other, so on and so forth. And follow that, we have to make sure that besides looking pretty, these feature actually works. Like when you click on a button, it actually fires an event and does something for you, and that something has to be as you expected, not something else. Go beyond functionality, we also have performance testing to make sure that the product, when under pressure, still perform at an exceptional performance rate. For example, when we develop in our machine, we don't have a lot of traffic like we have in production. So everything works fast and great. But if we don't account for performance, when we release a feature into production, soon enough, we will see that with a lot of traffic, we'll start seeing latency or even timeout or even outage as well. So performance test is absolutely crucial for a large product with a large size customer. Also we need to make sure that our product is compatible in different, like our software is compatible in different browsers. For example, if it works in Chrome, it should work in Firefox, it should work in Opera and even Internet Explorer, for example. Different environments. What I mean is at Gitlab, we have our shared environment, but we also offer self-hosted, and that is its own environment. And with different configuration, we have to make sure that the product works there as well. And not to mention different device, if it works on a browser on a computer, it should work on the browser, on a mobile phone, for example. And even different product version, we support at least one version older, or for customer who doesn't want to upgrade just yet, and to have to make sure that the older version also works as well. And we also make sure that the tests are working as expected. Like we also test the tests. We have to always capture the test data, monitor, make sure that the failures are actual failure. Otherwise, the test is considered flaky, and we have to make a judgment, maintain, and even improve the test. Add more tests or taking out the tests that are not in use as well. And last but not least, we have to ensure security. Make sure that when we release the product, it does not expose any security flaw or vulnerabilities that can harm ourselves or our customer. For test methodology, you can see here in the picture, we call this the test pyramid. What it means is that it demonstrates the ideal proportion that we want between different types of tests in a software product. As you can see, unit test is in the bottom, so we want a lot of unit tests. We actually want unit tests for every single unit of code. Is not redundant, it's necessary. But when it comes to integrated test, which is when we combine the unit test into a feature or between a group of feature, then we need less amount of tests. We only test that specific feature or the specific group of feature. And then the last type is end-to-end tests. And we don't want a lot of these, but they are very important because it's test the meaningful, complete user flow, just like a user is actually using our product. So these tests are very, very complex to set up, I would say. And so it is time consuming and expensive. So we don't want a lot of them, but we definitely need end-to-end tests in our suite. And so unit tests should be small and very fast. Integrated tests should be a little more complex in the setup and in the expectation, a little slower, but still fast. And then end-to-end tests is the most complex one and the slowest one as well. And let's use a example here of a make a cup of tea pseudocode. As you can see here, we have many steps in order to make a cup of tea. And let's imagine that we have a K-cup machine. And so as you can see, the outermost point would be the main steps. I'll call them main steps, like get things. So when you create get things method, you will want a unit test for that method. And what do we test for? Well, we test that get thing when called, it does not return null. It has, I'm assuming we are returning an array of items here, so the array shouldn't be empty. And the array return the exact item as we listed here, no more, no less, and or don't return anything twice, or don't return anything that doesn't belong to the list. And then, as you can see, the next step, we have 2 sub-steps. So I would say all 3 together, let's call them a feature. And so in prepare K-cup and cup feature, we definitely need unit tests for each step, the main step and the 2 sub-steps. After that, we have 1 integrated test for the feature where we combine all of these steps together. And we have a test that makes sure that when prepare K-cup and cup is triggered, the machine has exactly 1 K-cup, and the cup is located exactly underneath the machine, for examples. And then go through all the steps. After we finish, we want to have 1 end-to-end test for the entire process, which is, for example, in the test, we will start the process with calling getThing, calling prepare K-cup, start the machine and call the machine and call taste, and then at the end we want to test that there is cup in the there's liquid in the cup and the liquid tastes like tea. Then the test is successful. I hope that is useful. And I do want to mention quickly the difference between a quality engineer and a software engineering test. The quality engineer is very well known in the name quality engineers is pretty well known and familiar in the industry because it has lived a quite long time. But today we have a fairly new position called software engineering test, or most of the people would say SET or SCT. And what makes these two positions different from each other? Well, quality engineer responsibility is, as we have discussed throughout this lecture, that the engineer would ensure that the implementation of new feature works as desired. The product itself works as a whole, and the new feature does not break the product. There's no regression, so on and so forth. And the quality engineer would get involved at different times in the product development, depends on what kind of software development lifecycle model the company chooses. What I mean is like they could involve very early or very late at like right before we introduce the product to our customer. In other words, quality engineer is responsible for black box testing. Now, software engineering tests also responsible for quality assurance practice, but SET would approach this quite differently. Software engineering test is a software engineer who is responsible for creating and maintaining the automated test platform for the company's products. So after we have created this platform, we then engage and promote the testing practice throughout the software development process to pretty much everybody in the engineering department. Like I mentioned earlier, if we want to start early, and here at Gitlab we call the practice the quad planning process, and we want to start it during the design phase. We will follow very closely with the product manager and the development team of how they want to design the product and how they would want to implement those design proposal. And then we will make the suggestions of test coverages accordingly for the developer. And then we will help review the merge requests for the test coverage. And our ultimate goal is to actually make testing is everybody's responsibility, and to ensure that it can happen, SET must ensure that we provide everyone with the tools that they need and the opportunity that they need to test their work. And how do we do that? There are some examples. We create a framework called end-to-end test at Gitlab. And on top of that, we create a Ruby gem called Gitlab QA. What it does is orchestrate all of the requirements, set up, and then execute the test automatically in any given environment, give it a live environment or a non-live environment. And so to help not just developer, but hopefully customer as well, to execute tests on demand. And also with all of these tools, we can incorporate these tests into GitLab CI. Like in your merge request, when you create a merge request and make a code change, all of the tests are automatically run for you and make sure that the code doesn't break the product. And here is testing at GitLab in a nutshell. As you can see, we have a little pipeline module from a merge request in our GitLab repo. So one of this, each of the circle is a stage, and one of these stages will be a test stage that will run all of the unit tests and integrated tests, and the result will be reported. And if any of them fail, we'll not allow the merge request to be merged. And then at the end, you will see where the exclamation mark is. That's where we trigger a job called package and QA, which use the GitLab and QA gem in a downstream pipeline, and then automatically do all the setup, run all the tests, and report back the results for us. We also have a smoke and reliable test suite, and if any of these fail, we will block deployment. It won't allow to be released into production. And I also have a little demonstration of how GitLab QA works here. So GitLab QA is a gem, and when triggered, it will spin up a Docker container called GitLab QA container. And then in this container, we will specify what kind of scenario we want to run, and run that test of that scenario against whatever GitLab instance we want. Is that give it staging environment or another Docker container that hosts the GitLab itself, or our development toolkit, so on and so forth. And lastly, I would like to share with you some important skills in case you want to become a software engineering test. Definitely learn and know about software testing and the methodologies used in software testing, like we have discussed here in this class, and also know about the different software development methodology, like Agile, DevOps, Waterfall, Rapid Application Development. Why are they different from each other? And why your team uses those, and how to test, when to test in each different method. Very important that you know and familiar with the common tools and technologies that are used in today's software development. To name a few: Docker, Gitlab, AWS, Sentry, Postgres, Elasticsearch, and definitely programming languages. But this really depends on the software that you'll be working with, because each software has their own tech stack. But we can use example from GitLab stack. So definitely know Ruby, Golang, JavaScript, SQL, etc. And that concludes our session today. Hope you have enjoyed our class, and most importantly, learned something new about software development. Testing is very important and definitely a great skill to have in your skill set. Always test your code no matter how confident you are. Happy developing and thank you. Bye.